Somehow my camera phone is opening up in portrait self-look mode, and I'm wondering who is that rascal in my laboratory playing with my trains. Oh, and then I hit the button and I get where I want to be. What I want you to see is this experiment is working a little different than I had thought it would, but it's working, okay? Inside the that lid, there's a heater. You can see that. The blue wire coming out is actually a temperature probe, so we're at 117 degrees inside there, Celsius, right? The very fine gold-looking wire coming out is the thermistor. That's the sensor that's sending back the signal of the temperature in ohms, in resistance. So when the resistance or the temperature goes down, oh God, I touched something, Jesus. When the temperature goes down, the ohms goes down, ohms go up. There it is. And when ohms goes up, then the voltage will go up. So if the temperature was sitting around, what did I say it was, 117, something like that? Sitting around 117 a few minutes ago, and I've moved it. I went to scratch my nose. It's just crazy. All right, so we're going to wait till it climbs up. I apologize. Okay, fine. 110, 430. It's not perfectly calibrated, but the proof of principle is here. I'm going to show you. So this heater would sit on this engine, and this fan would blow a puff in. Every once in a while I go puff, puff, and you see smoke come out. Chuff, 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 chuff. The problem is every time that fan puffs, it cools down the heater. And if you keep going, the heater will cool down and you'll lose smoke. We're getting smoke right now, so we're up around 113. Okay. Settling in a little bit. It's still going. So we're at 4.26 voltage. This is set for 6.3 volts max, max. And then this is, or 6.5, excuse me. And so we're getting 4.25 coming out, and that's getting us to the 115. Now, I'm going to blow on this as if I'm puffing, and you can watch the temperature, and then we'll go look at the voltage and see what it did, okay? So I'm going to blow on this. I got it. I'm doing a movie. I'll be right up. So we got it down to 85, and we're at 4.3, 4.4 volts. So it went up. That's the idea. And the temperature is climbing right back up. So if the fan were to puff, we get more volts. I'm going to see if I can... What? Oh, it timed out because I've been sitting here for 4 hours. All right. Now I really got it down in the cooler, and we're up almost to 4.4. And it's climbing right back up. That's the idea. Now, I'm not optimized in my voltages, my resistances, my blah, blah, blah. But right now I'm figuring out the mechanics of how this is going to work, and sensitivities and such as that. So as this climbs up to the 120 range, then the voltage should decrease, and it does. I've watched this a couple times in between being yelled at to come upstairs and everything else. But in any case, this is where I'm at. Now, I would have hoped if it went down to 70 degrees, it would have climbed up to higher than 4.4. It would have climbed up more like 6, and it would have heated up faster. What I don't know is the reaction time of the thermistor and the reaction time of the chipset that I'm using, this 317. If their reaction times are slower, then that's going to delay this action, and it's not going to be real time. It's closed loop, but not real time. So I'm going to have to stay and watch and keep an eye on this thing. It's getting up to 114. I didn't jostle anything else out of whack, did I? I don't think so. 116. Well, yeah, it's coming down. 130. So it was 4.39, now it's 4.29. Temperatures are approaching the 115. We'd like it to be a little hotter for a little longer and then cut down. So I may have to change my reference resistor. I may have to change the input voltage. I'm not sure exactly what piece is going to have to change, but I'm going to have to tune this up a little bit to see what we get. And we should be getting 1.6K resistance, and that puts us in nearly 70 degrees, so I don't understand that. So I'm getting conflicting readings, but I found out that when I plug in the meter, that affects, if it's in a circuit, it affects it. You can't just take an ohm rating and not affect the system that you're controlling, so it's really weird. Now look at it, we're up to 120, but the temperature is still going down to 227. So that's good. We don't want this to get much hotter than that. So 4.25, 1.2, now it's coming down. So it's settling right around 1.20, 1.21. Here, see that? 1.21. 1.21 at 4.24 volts going in. Now it's sort of like a baseline, so now I can go back and do the math and figure out, well, if I really want this, then what, and blah, blah, blah. So that's that. I think we're okay. I would like that to be 120 at, well, it is what it is. This is the machine. So, okay, what I would like to do is when I cool it down, it jumps up faster. That's what I would like. It goes to 4.5 here. We'll watch it again. I'm going to blow on it right now. I'll cool it down. You see what happens. I blew it down to 70 degrees, and you see it does climb up, but it's heating back right up. So the sensitivity is right there, right at that point. So it's up to 110 already. So it'd be making smoke at this point. 110, 90 will make smoke. 80, 90. It comes right back to 80, 90 real quick. 20 is overheating. So we're not too far off. All right, that's it. This is really long. I apologize, but this is where I'm at. This is what's going on. We've got a volt regulator with actually a rectifier first, going from AC to DC. Volt regulator set at 6.5. A variable volt regulator with settings that are hard to explain, but we got a base resistor at 470 and then a variable resistor monitoring the temperature. And we're holding it below 120, and if it cools down, the volts climb from 4 to 450 or so, and then it gets hot again. So it's doing that. Now I just need to dial that in a little bit. All right, later. Thank you.